Okay, in the last lesson we learned about just the formulas and how to actually calculate area and circumference. This lesson is more on how those things would be applied with some daily live things. Okay, so the first one, I'm just going to go through a couple examples here, and that should give you some indication of what you need to do for your practice. Problem number one. The diameter of a cartwheel is 2.1 meters. Find the distance traveled when it completes 100 revolutions. So I'm just going to go ahead and draw a cartwheel. It says the diameter, so all the way across, is 2.1 meters. Find the distance when it traveled 100 revolutions. So distance would be an indicator for circumference. Okay, they want me to know how far around would it go in one revolution, and then I need to take that times 100. Okay, so circumference, when I'm using the diameter, I'm going to use pi d. The diameter is 2.1 times pi is going to be about 6.6 meters. Okay, and that is one revolution. When I go around this circle one time, that's one revolution. That's also dealing with the circumference. So if I want to know how far it's going to travel with 100 revolutions, I'm going to take the 6.6 for one of them times 100 times it's going around, and that's going to give me, move this decimal over two places, 660 meters that it would travel when it went around 100 times. Problem number two, the radius of a circular park is 63 meters. Find the cost of fencing. This also would be a good indicator for circumference when you're going around the outside edge. Let's draw our circular park. Radius is going to go from the center out, and it's telling me that radius is 63 meters. Okay, so I need to figure out how many meters it is going around so that I can calculate the cost of the fencing. So again, I'm going to use circumference. Because I'm given the radius, I'm going to use 2 pi r. So 2 times pi times r. And when I make those calculations, it comes out as 395.8. Now, when we're dealing with fencing, we probably aren't going to get that exact. So we're just going to go ahead and round it to 396. Many times on problems like this, it's going to tell you exactly what to round things off to, okay? But this is kind of a practical application problem. So it's going to go one time around. It's going to be 396 meters. That's how much fencing I need to buy to go one time around the park. Each meter is $12. So 396 times $12 is going to be $4,752. The last one, problem number 3. A goat is tethered by a rope that is 3.5 yards long. What's the maximum area? Well, that kind of tells us what to do. That the goat can graze. So if I think about it, if this is my point where the rope is attached, it's going to come out here. The rope is 3.5 yards long, and that goat can go all the way around in a circle here. Okay, so it wants to know how much area can that goat graze? How far can it go? So that's area, pi r squared. So the radius of this problem was 3.5 squared times pi. Okay, when you're going to multiply that out, you're going to get 38.5 yards squared. Okay, I guess we didn't focus or concentrate on that too much when we were doing our equations, but if application problems, it's good to make sure you're labeling all of your answers, like I did up here. Meters for that one, dollars for this one. This one is area, so we always talk about square units when we're talking about area. So there's a couple examples of when you need to use area, when you need to use circumference. It's good to draw a picture. Okay, put the information on the picture, write out the formula you're going to use, plug into the formula, and then do the calculation. So if you have any questions, let me know.